condensation of water takes place. So how this rainfall happens, you guys already know that whenever the temperature is too low, these water droplets in the cloud, they will start to freeze into crystals of ice. Getting it? First, they will freeze into crystals of ice and come on Earth slowly as let's say snowfall. But let's say during winters, especially the snowfalls are seen during winters. So during winters, what happens? The temperature will fall after sunset. The temperature falls after sunset. During the day, it is comparatively warmer. So that causes condensation of water vapors near the ground as well. And these droplets hang in the air to form fog. Getting it? So condensation of water takes place there. Okay. So condensation might either it might lead to conversion of water vapors into water droplets, right? Or if the temperature is too low, what will happen, guys? The water will condense. It will not condense. It will basically freeze into ice. If the temperature is too low, then water droplets freezes to ice, right? And that leads to snowfall. And here it is simply rainfall. Getting it? And especially during winter hours, after the sunset or just before the sunrise, right? So you will see that the water vapor close to the surface, due to very low temperature, the water vapor present in our surrounding in the lower layer of the atmosphere, they will also start to condense, and that leads to fog, isn't it?
Yes, sir.
Okay. So
Yes.
since we are talking about rainfall, we have also got certain instrument to measure the rainfall now. So what is the instrument that we use to measure the rainfall? Hmm? Any idea, guys? Instrument used to measure rainfall. It is called as rain gauge. RAIN, rain, GAUGE, rain gauge. Right. So what is a rain gauge? It is simply a cylindrical structure like this, like a beaker with scale marked on it. Right. So the marking of scale is basically in millimeters and centimeter. Right. Okay. So rainfall will be generally measured in millimeter. Remember this. Rainfall is measured using rain gauge, and the unit in which it is measured, it is in millimeter. Are you guys getting it?
Yes.
Okay, good. So that will be measured in millimeter, right? Okay, so basically what happens whenever there's a rainfall, this beaker will be collecting rain droplets, rainwater. And when the rainfall stops, the amount of water collected in this beaker will basically tell the amount of rainfall in that particular region, right? Getting it?
Yes, sir.
So this is basically a measuring cylinder which we are talking about here. The rain gauge is nothing but just a measuring cylinder with scales marked on it, right? Okay. Now talking about temperature, guys. So what is temperature? Remember, we are talking about elements of weather. Getting it? So if you were to talk about temperature, generally we talk about temperature of human body, temperature of different substances. But in context of weather, what do we talk about? Hmm? And what is actually the factor that affects the temperature of the Earth's environment, the atmosphere of the Earth? Any idea? What is the factor that is responsible for temperature on Earth, basically? Hmm?
Mhm.
No, I'm talking about the source of the heat, right? Look, our weather, the weather which you see, it is mainly affected by the sunlight. And this sunlight, it's the sun that gives off sunlight, and due to the heat produced by it, the temperature of the atmosphere of the earth is raised, right now. So you see, the sun is providing you both light and heat on earth, and we all know that it is necessary for the production of energy. Which form of energy I'm talking about here? Sun is responsible for production of energy. Huh, Sundus? Production of energy. Which form of energies sun is responsible to produce on earth?
Heat.
Heat, obviously. Heat is heat is basically absorbed by the sunlight by the different surfaces of the earth. Okay, apart from that, you see, the light energy, if you were to talk about the light energy coming from the sunlight, how this light energy coming from the sunlight is absorbed by the earth, or absorbed by the features on earth. Features on
What,
earth.
sir?
How light energy from the sunlight is utilized by the features present on earth. Like features present on earth are what? They are like plant, soil, mountains, oceans. So how the light energy is utilized? We all know that it is particularly taken up by the plants in the process of photosynthesis, right now. Getting it?
Yes.
Okay.
Yes, sir.
So coming back to our topic, the weather which we are talking about here is mainly affected by the sun that produces heat and raise the temperature. Getting it? So it will eventually raise the temperature, but it will also impact environment in certain other ways. For example, there's a region where the soil is fertile, soil is good enough to produce crops, everything is there, water availability is also there, but the region receives very less amount of sunlight, right? Only for let's say a few days in a year. Will there be enough growth of vegetation of plant enough growth of vegetation in that area?
No.
No, obviously no,
No.
right now. So sunlight not only increases the heat of the earth's surface and the earth's atmosphere, it also influences the amount of vegetation in the area. Getting it, guys? Okay.
Yes.
Now talking about the oceans, you see the heat from the sun is absorbed by different surface of the earth, right? It is also absorbed by oceans also, right? So it plays an important role in marine life as well. So it also determines the weather of oceans as well. Weather of ocean, what does it mean? Like the fishes, they too have a weather, no? Like fishes live under the oceans, under the water. They too have their own environment. For
Yes,
certain
sir.
part of the certain part of the year, they are receiving better, a greater amount of insolation. Insolation, basically the amount of sunlight that is reaching on the Earth's surface, that is called as insolation. And for certain months, they are also receiving lesser amount of sunlight. Right now. Okay, now as we are talking about oceans here, there are aquatic plants in the oceans as well. Yeah. So they also photosynthesize, they also do the process of photosynthesis. Right. So the amount of insolation also influences the aquatic plants life also. Getting it, guys? Okay. Now talking about other factors like humidity. What is humidity? Anyone? Like
The amount of water vapor present in the atmosphere.
hmm, the simply it is defined as the amount of water vapor in air which causes dampness of air. Humidity is responsible to cause dampness in air, right now. So usually in summer season, when there's rainfall as well, right? So the environment becomes very damp. There's too much of humidity, right? And it is quite uncomfortable. Getting it? So where the water comes, how the air is able to hold water? The question here lies that how air is holding water. Huh, Sundus? This is, let's say, a portion of air mass we have taken here. So why air can hold moisture? Mm-hmm. Yes, Sundus, are you there?
Yes, I'm there.
Yeah.
Humidity,
So
I think.
it okay, we are talking about humidity. My question to you is that how air has got why air has got the ability to hold water? Because there is empty spaces now in between the air molecules. Yeah.
Yes.
See, there are too many empty molecules. So in between these empty molecules, tiny, very tiny droplets of water get can be present there. Okay, so that's why we say that air has got the ability to hold certain amount of water vapor. Right now air has got ability to hold water vapor. Getting it right now? Okay. So how the ability of air to hold water vapor changes? You will see. If you were to say increase the temperature of the air, will it be holding much more amount of water vapor or will it be holding lesser amount of water vapor? What do you guys think?
What's up?
If you were to increase the temperature of the air, will it hold more amount of water or will it hold lesser amount of water?
So,
Like,
less amount water.
no. The capacity of air to hold water will increase as you will increase the temperature. Getting it here? Look, answer me this question, that why during winters our skin gets dry. Yeah, our skins become dry now during winter.
Yes,
Yeah.
sir.
Okay, why is it so? Because the air, as the temperature of air is lower, its capacity to hold water vapor decreases. Getting it? So there is a direct relation
Yes.
here. Okay, the direct relation between the temperature and humidity can be seen here. If the temperature is increased, okay, like let's say that let's say like during a particular sunny day, let's say there's rainfall as well. It's a sunny day, but usually we see that during sunny days also there can be rainfall, a sudden rainfall. So after rainfall, you guys must have seen it becomes too humid now. Yeah, haven't you guys observed?
Yes.
Why? Because the temperature of the air was already higher and now it's rainfall. So the amount of that air to hold water vapor increased because the air was already warmer. Getting it, guys? Okay, so that is the thing here. Okay, now question comes here: how do we measure humidity? How to measure humidity? To measure the presence of water vapor in the air, we have also got an instrument, and that instrument is called as hygrometer. Hygrometer. Getting it? Okay. So hygrometer, this hygrometer now basically is made up of two thermometers, right? Okay. And the bulb of one thermometer is wet, and while the bulb of other thermometer is dry. So it consists of two thermometers, right? Let's say these are two thermometers, and the bulb of one of the thermometer will be wet while the bulb of another thermometer will be dry. What are we talking about? We are talking about hygrometer. Getting it? Okay, that's it. What you need to know about instrument. Nothing too technical about it. All right, guys. Then you have, okay, please do tell me if you guys have any confusion so far. The concepts are too basic and too simple. Yeah,
Yes, sir, it's clear.
that's clear now.
Yes.
Okay, good.
Yes.
Now moving on to next element, like you have got storms of winds. They can be collectively studied as wind speed here, right now. So what is wind speed and how is it caused? You guys have to know that there's a temperature difference right now. Some part of the earth receives more amount of sunlight, some part receives lesser amount of sunlight, right? And if the sunlight is falling equally on land and it is falling equally at an ocean as well, or the ocean will be, obviously you will see the temperature, obviously you will see the air above the land will get heated more quickly and it will start to rise right now, while the on the air on above the ocean will comparatively be getting warmer but slowly right now. So suppose, let's say the temperature of the air above the land is, let's say, 42 degrees Celsius, but at the same time, same hour of the day, you will see the temperature of the ocean, let's say it will be around 30, let's say 38 degrees Celsius. So where the pressure will be lower, we know if the temperature is higher, the pressure is lower. Yeah, that is the inverse relation you guys are aware of, isn't it, Sandhu and Vaiga? So here the temperature is
Yes, sir.
higher, right? So pressure will be lower. Okay, and here the pressure will be higher, here the pressure will be lower. So we know air molecules will move from a pressure of higher region to a pressure of lower region, towards this side, right?
So can you explain it one more time?
Yeah, sure. Look here, what is happening? The simple thing is that on the land side, let's say we have assumed that the temperature of the air molecule is 42 degrees Celsius. So what does it mean? If the temperature is high, pressure is going to be lower, right now.
Yes, sir.
Now, on the ocean side, we know that water molecules also cools down very slowly. Sorry, heats up very slowly, right, as compared to land surface. And here you will see the air molecules above the ocean. They are also going to be getting warmer, but comparatively slower, right now. So let's say at the same time of the day, the temperature above ocean is 38 degrees Celsius. So since the temperature, if you were to compare the temperature, both the temperatures here, 38 degrees Celsius, it means that the pressure in this region will be higher if you were to compare it with the pressure over the land, right now. So here the pressure is higher while the pressure is lower in this case. So there will be flow of air from ocean side to land side. So basically you will see the wind is basically caused due to the difference in air pressure. Yeah, wind is basically caused wind is basically caused due to what? Air pressure. So it moves from a region of higher pressure to lower pressure. High pressure, what does it mean? High pressure basically means lower temperature, from a region where there's lower temperature to a region where there is higher temperature. I will get you an example, then it will become more clear. Okay, you guys must have heard about westerly disturbances, western monsoon. Yeah, this year it reached very late in northern parts of India. So where does the western monsoon come from? It basically is due to the Arabian Sea, no? Yeah, on the western side of Indian Peninsula, you have got Arabian Sea, and moisture laden winds from the Arabian Ocean comes to northern part of India, and there it leads to rainfall. So you see, this is your land here, and this here is ocean. And the let's say if the temperature here is 38 degrees Celsius, the temperature here is 42 degrees Celsius, isn't it? Just taking up example here. Okay. So obviously there's a flow of air from ocean towards the land surface, and that air along with it carries the moisture also. Is the concept clear to both of you? Hmm? Yes? Sundus and Vaiga, please do say yes or no anything.
Can you explain again?
Okay, sure. Look what happens. During the summer, you will see, as I gave you one example here, the wind blows from Arabian Sea towards the land surface, or it also blows from Indian Ocean and Bay of Bengal, right? For example, here you have map of India. Let's say I'm drawing only the peninsular map, right? Here it's Bay of Bengal. You guys know about this Bay of Bengal, and here it is Arabian Sea. Getting it, guys? And here it's Indian Ocean. No? Okay. So during winters, what do we observe? That winds blow from Arabian Ocean, it blows from Bay of Bengal, and it also blows from Indian Ocean also towards the surface of India, towards the land here. So here, let's say it's a land, obviously, right? And here you are seeing it's ocean. Getting it? Now the simple concept why wind flows, right? Why basically wind is there? Why wind occurs? It is due to the pressure difference. It is due to the pressure difference. Now, so talking about the pressure difference, how pressure difference is generated, the simple concept of pressure difference is that the air will move from lower temperature to higher temperature. The air molecules will move from lower temperature to higher temperature. Getting it?
Yes.
So land breeze and sea breeze, in that you guys must have studied about this right now. So say during day, we are talking about daytime. This is your land surface. This is your ocean, right? Okay, just giving an example here. So we already know that the air molecules above the land, or land simply, it heats up faster and cools faster, right? While the ocean surfaces, they heats up slower and cools down also very slower, right? So that's why you will see in deserts it will be too warm during the day, but during the night it will be too cold. Why? Because land surfaces warms up also very fast and cools down very fast. Is it clear? Yeah. So during the daytime you guys will see that the temperature here will be higher, the temperature here will be comparatively lower. We are talking about temperature of air molecules. Air molecules. And the basic concept of wind speed is it is simply due to the air difference, air pressure difference, air pressure difference. So it also further says that the concept of wind basically is further says that air will blow from a region of um, higher pressure to lower pressure. Yeah, from higher pressure to lower pressure, guys. Right. Okay. Now look at this figure here. Look at this representation here. The air molecules at the ocean side, they are comparatively cooler as compared to the air molecules above the land, right? So what does it mean? The air molecules will be going towards the land side now during the daytime, right? So basically it's the flow of wind now. That's why people living in the coastal regions, they get to have winds coming from the oceanic side. Getting it, guys? Yes, Sundus and Vaiga. It's a very simple concept here. Hmm? Please say something.
Yes, sir.
Yes.
Right? Okay, so that's why in the same manner you will be seeing that from Arabian Ocean or Bay of Bengal or from Indian Ocean, wind blows towards the land. That leads to precipitation also. That leads to rainfall also because they carry moisture laden clouds. Winds carry the moisture from these water bodies towards the land surface. Okay, hope that is clear to both of you. Okay, so in short, we have talked about different elements of weather here, right now. Okay, so whenever a weather is predicted, whenever you will see the weather forecasting, this is done by the scientists called the meteorologists, whom we say as meteorologists. They basically study these datas right now. That's why they are able to predict that it might be rainfall today, it might be sunny, it might be cloudy, right now. It might be stormy, or there might be lightning or thunderstorm, right? Okay. Now, there's another concept called as fronts. What is fronts? Any idea? Look over this figure here. Hmm. Look, look over here. There is cold air coming from this side, and there is this warmer air. And you can see there's a imaginary boundary between the two. Yeah. Just simply look at this diagram. Yeah. Okay, this illusionary boundary that is created between colder air and a warmer air, that is simply termed as weather front. Getting it? And here we have called the air of warm air as air mass simply, and we will also call the air of cold air as air mass. Like we humans have got some mass, the air has also got some mass. Getting it? So the density is also going to vary. Density, you guys know. Yeah. So since colder air, it means it has got what? As compared to warmer air, colder air has got more amount of water vapor in it. Yeah. Am I visible or not?
Yes,
Just
sir.
okay, okay. Here it's showing meeting disconnected. Am I still visible?
Yes, sir.
Okay, okay. Yeah, yeah. There was some technical issue. Anyways, so here you see a weather front is simply a boundary that separates two masses of air of different densities. So colder air and warmer air, they have got different densities, right? So warmer air you will be seeing here, the warmer air, they are lighter in nature now. Warmer air, they tend to rise up, getting it? The molecules of the warm air, they are light. That's why the arrow you can see here, the warmer air are rising up because they are lighter, and the colder air are rushing towards the gap created by this warm air. Like since the warm air is rising upwards, so there shouldn't be any vacuum created in this region. So that's why the cold air rushes towards that region to take up the empty space created by the warm air. Getting it, guys? Okay, so in geography, weather front is simply the concept as an illusionary boundary between the two masses of air which have got different densities. Why densities? Here you see warm air and the cold air will have different densities due to the amount of varying water vapor present in them. Any confusions? Okay. So they will also differ in temperature and humidity also. Okay, now you guys tell me which air will be having more amount of humidity, warm air or cold air? Which one has got more humidity? Just a simple reasoning question. Just apply logic. Hmm? Yeah.
So, what is the question?
My question is that which air, cold air or warm air, will have more humidity? Mm-hmm. Yes. Which one will be having more humidity? Sundus and Vaiga. Please do answer this question. Like the warm airs you see, warm airs, they are going to rise up and then they are going to form clouds also. They are responsible for formation of clouds now. So they must be carrying water vapors along with them as well now. Yeah. See this here is a water body now. Getting it? So they are carrying water molecules with them as well. And as we already studied moments ago, that if you were to increase the temperature, then humidity also increases now. Yeah. So the air molecules, the warm air molecules, since the temperature is higher, the amount of water vapor they will be carrying, that will also be higher. Hmm? Any confusions? Please do tell me. Sundus, did you got what I just explained? And Vaika,
Yes.
Yes, sir.
right now? Okay. So weather is produced by the interaction of several factors that include these things. Like whenever we will be talking about weather now, we are not only talking about rainfall, or we are not only talking about the temperature, right now, or we might not be only talking about wind speed. It's a culmination of all these factors here, right? So it's not that I am only feeling cold today. I'm only feeling hot today, right? The weather might be a little bit windy as well, right? There might be some amount of humidity in the air as well. Yeah. The amount of insulation might be lower, might be higher. Sundus, by the way, what is insulation? Insulation. Yeah. Insulation. What does it mean? I have been using this term. Please to tell me what is insulation. Mm-hmm.
What, sir?
I have written the term here. Insulation. What does it mean? Or Vaika, you can also answer this.
The sun rays.
Sorry. Not the sunrise. The amount of sunlight that reaches the Earth's surface. That is simply called
That's
as.
what is not rays.
That's what you said.
Yeah.
Okay, okay. Sorry about that. I might not have heard it properly. Okay, good. So that is simply insulation. And do we get 100% of sunlight? Hmm? Do we get 100%? Hmm?
No, we
No.
don't get.
Obviously, we don't get 100%, right? No. Because if we were to get 100%, life would not exist on Earth, right? The water will be simply evaporated into the universe, basically, into space.
Yes.
So several factors that includes here are temperature or heat, humidity or amount of water vapor in the air, wind and atmospheric pressure. Yeah. So atmospheric pressure, what is it? It is simply the pressure generated on the surface of the earth due to air mass. Right. So this is your earth here, and there's a blanket of layer surrounding the earth that we call as atmosphere. And especially in the lower levels of the atmosphere, where the density of air is higher, where higher water molecules are found. Air molecules are found. Apart from that, you have got dusts also, different types of gases also. So in the lower level of the atmosphere, you will see that there's a higher pressure, right? So that pressure we are calling as atmospheric pressure. Simply the pressure generated by the air molecules on the surface of the earth, that is atmospheric pressure. And as you will move above, if you were to go at elevator surface, for example, Mount Everest, what do we observe there? Hmm? You observe nose bleeding. Yeah, you feel there's a nausea. The person goes through nausea. Why is it so? Hmm? Yes, guys, please do participate in the discussion here. Why is it so
What,
that?
sir?
Why is it so that when a person goes to a mountainous region, they suffer from nose bleeding or no, they goes through nausea?
Because of
There
the
is
cold.
less,
Okay, Sundus, you please answer first.
because I think so there is less oxygen.
Okay, there is less oxygen. Okay, the point is true. The statement is true, but that is not the correct reason here. That is a correct fact that there's less amount of oxygen there. Okay, Vaika, you?
So due to the like cold.
No, no, no. Cold is there obviously, but that is not the reason. Look here, what happens now? This human, okay, this human is standing here on a basically not at a very high elevation, and there's another person who is standing here. What happens now? We are also surrounded by the atmosphere, the air molecules. Look over here. How much of air molecules are exerting pressure on our body? So why we are not collapsing? The reason is that the blood flow in our body, the enzymes that flows in our body, that also creates a pressure. And external pressure is created by the human body also. Why? Because of the metabolic activities that goes inside our body, because of the blood circulation, that also creates pressure. The blood pressure which you measure, that is BP. So that is why. That is what? Simply the pressure at which the blood is being pumped into our nerves by the heart. Okay, likewise, apart from the heart, there are other enzymatic actions, metabolic activities in in our body that also generate some amount of pressure. So the pressure generated by our body and the pressure exerted by the atmosphere on our body, that is balanced. Right now, that is balanced. That's why our body does not erupt or our body does not feel atmospheric pressure. But if the same person was to travel to Mount Everest or any other mountains of certain height, so there what happens now? The air is very thin there. The air molecules are lesser. On the mountain Everest, you don't see dust particles, or you don't see so many amount of gases in the atmosphere. So basically, the air molecules are lesser there. That means thin air is there. That also means the pressure being exerted on the body will be lesser, isn't it, Sundus and Vaiga? But
So
will our body also reduce the pressure? Will our heart stop to pump the blood at a lower pressure? No, obviously no. Right. So our body is exerting pressure at the same rate, while the pressure around our body, pressure of the atmosphere has reduced. That's why blood comes out of the nose. Got the concept? Yeah. So basically,
yes, sir.
pressure generated in our body becomes greater than the atmospheric pressure. Right now, that is the reason. Then other factors like you have got wind speed, then you have precipitation, cloudiness or the amount of cloud cover, right? Then visibility, that is how far you can look into the horizon. Horizon, who will explain to me what is horizon? Sundus, explain to me what is horizon. Hmm?
What, what is what?
This here, horizon. Yeah. Or Vigo, if you like, you can also answer it. Yes. Look, it is nothing but it's just a illusionary line, right? Like whenever you will see the sunset, right now, you will see that sun is, let's say, sun is now basically dipping into ocean. Let's say, like it seems like it is dipping into
Type
ocean.
of that is horizon.
Yeah. Or
So
if you, yeah.
1 minute, sir. Can I go drink some water and come?
Okay, sure, sure. Okay, Sundus, you were saying something.
It is that orange type of line. Orange
Hmm.
yellow line.
Good. Okay, look, what is simply horizon now? If you were to stand in an open field, Okay, you will have a better view of horizon, right? So it is simply the area where the sun looks like it's about to what do you say? We can put it like this way, that during sunsets, while the sun is setting, you will see there's a line created between the land
Sir,
and the sunset.
sir,
Yeah, Vaiga.
I'm back, sir.
Okay, okay. So we are discussing the same thing here. Right now we are talking about horizon. So you will see during the evening time, during the sunset, you will see when the sun is about to set, when the sun is about to disappear, it looks like it's disappearing while it's still there. So you will see there's a line that is created between the sun and the land surface. So that is simply called as horizon. Okay.
Okay.
Yeah. Now moving on, how do changes in weather occur? That is the question. Hmm? So whether you are talking about wind speed, or whether you are talking about temperature, or whether you are talking about precipitation, or whether you're talking about humidity, all of these all of these weather factors are being influenced due to sun only. Getting it? Everything is related to sun directly. Hmm? Whether you talk about temperature, whether you talk about rainfall or humidity, hmm, or whether you talk about wind speed, aren't all this connected to amount of sunlight that reaches earth? How how is it so, guys? Let's say if the insolation received by the earth is higher, it means the temperature will also increase. Now the amount of sunlight coming is higher, it means temperature will increase, right? Okay, also if the temperature increase, it means that there will be much more amount of evaporation from vegetation and from water bodies now. Yeah, isn't it? So if
Yes, sir.
the evaporation increases, what does it mean? It means this will also lead to rainfall also. But the given condition is that there has to be water bodies and vegetation right now. Okay, so evaporation takes place from water bodies and vegetation. It means that there will be formation of cloud and more rainfall will be there. Yeah. And if there's more and more rainfall, it means humidity, that is amount of water vapor in the atmosphere, that will also increase. Okay. And moments ago, we also discussed about how wind moves from one region to another. It is basically due to air pressure. So somewhere pressure is higher, somewhere temperature is higher, somewhere temperature is lower. Right now, so air will move from higher pressure to lower pressure. The area where there's a lesser temperature to the area where there's higher temperature. Getting it, guys? So that is the reason why all the changes in weather is related to sun and sun only directly, right?
Yes.
Okay. No.
Yes, sir.
An interesting question here is that why days are shorter in the winter season? Anyone um, who has got any idea about this? Why is it so that days are
Because
shorter? Yeah. Go on.
like sun is not like there for much time. It
Sun
feels
is
like
sun is not there for much time. Okay. Vaiga, what about you? Hmm. Why do you think? Why is it so that days are shorter in the winter season?
Don't know,
Look,
sir. I don't know.
look at this diagram here. We know that Earth rotates on its own axis. Okay, am I visible or not, guys?
you are visible, but your hand.
Okay, okay. There's some issue over here. Anyways, okay. So you see, Earth rotates on its own axis while it revolves the sun as well. Getting it? So you see, Earth is spinning on its own axis around the sun. Okay. Now, if it's spinning and rotating around the sun as doing revolution around the sun as well. Look here. Here, this shows that the Earth is revolving around the sun, but the depiction is not 100% accurate here. The sun does not revolve exactly like this. Sorry, the Earth does not revolve exactly like this. The diagram is a little bit in the real scenario. It's a little bit different. Right now, sun is like slightly tilted in this side, but still, for convenience, we take up the same diagram. So you see, at particular time, at different parts of the revolution, you will see, for example, in this case, the distance between the Earth and Sun is maximum here in the two cases now. Yeah, maximum distance here. So what do we observe here? See over here. Here in this case, there will be summer in the northern hemisphere while there will be winter in the southern hemisphere. Why is it so? The question is, why is it so? You guys know about summer? You guys know about the southern or northern hemisphere or not? Like our Earth,
Yes, sir.
yeah, our Earth has been basically divided into two hemispheres. Spheres, you know, our Earth simply looks like a sphere. So we have divided into two hemispheres: northern hemisphere and the southern hemisphere. Right now, so when it is at this place here, at this position, the northern hemisphere of the Earth will be receiving more amount of sunlight, while the southern hemisphere will be getting lesser amount of sunlight. So there will be winter in the southern hemisphere. Now look at this one here. Here, winter will be there in the northern hemisphere, while summer will be there in the southern hemisphere. Okay. Just keep on adding the points. We will come to the conclusion in a moment. Then look at this position here. Isn't Earth close to Sun here? Yeah. So here you will see that this much part of Earth where there will be summer will be receiving much more amount of insolation. Since it's closer to Sun, the days are going to be longer. Same is for this one as well. Now come back to this slide here. What do we know that? Earth spins on axis around the sun, that is obvious. The amount of sunlight a particular region of the Earth's surface will receive, it will vary. Throughout the year, it will be varying because its position with respect to the sun changes because of the rotation of the Earth. So meanwhile, the sun is doing revolution, it is also doing rotation on its own axis. Getting it? Okay. So
Yes,
this
sir.
also leads to change in the season of a place as well. Yeah. We will come to season. Season, you guys know about it. Season basically over a prolonged period of time. If it's
I
too
didn't understand it.
okay, we haven't concluded yet. Okay, Sandas. So far, is the first 2 point clear to you or not? So no, you know, sun spins on its own axis now.
Yes.
Yeah, sun spins on its own axis. And while spinning on its own axis, it also spins around the sun also. Yeah, that we call as revolution. Getting it? Now here, look at this diagram again. At different parts of the Earth, different positions of different surface of the Earth are receiving different amounts of insolation due to their farness or nearness to the sun. Since their position from the sun is relative at different parts of the year. Look at position 1 here once again. Since it is farther away from the sun at this particular time of the year, so there will be winter in the northern hemisphere. So see, this northern hemisphere is slightly tilted here now. This northern hemisphere, and this is southern hemisphere. So this is receiving comparatively lesser amount of sunlight. So hence there will be winter in the northern hemisphere, and the southern hemisphere is receiving more amount of insolation. Let me draw it over here like this. See, this much of part is receiving insolation right now, and only let's say this much part of the northern hemisphere is receiving insolation. So which hemisphere is receiving more insolation, guys? Obviously the southern hemisphere, no? Okay.
Yes, sir.
So here we are seeing that there will be winter season in the northern hemisphere, right? Now look at this figure here, figure number 2, this one.
So due to the rotation, the weather changes, right?
Exactly. No,
So one second.
due to the
Can
rotation,
I,
you,
can I just
yeah.
leave for just 1 second? I have to just like,
Okay, okay,
there's an
okay,
event.
okay, no issue. Vaiga, due to rotation, now you observe day and night. Day and night is due to rotation. Weather is not due to that. Getting it?
Yes, sir.
Oh, okay. And talking about the season, as you said, now season, it is due to revolution of Earth right now. So
Okay,
here,
sir.
since it is farthest away from the sun, obviously in the northern hemisphere, you see the amount of insolation getting is lower since winter season is there. Here it's autumn season, right? Here it's spring. Okay. Okay. So this, from here on, from point number 3, we will continue from today, tomorrow. All right. Few more things needs to be discussed. Getting
Okay,
it?
sir.
Okay. Okay. Let Sandus join again, then we will conclude.
Okay, sir.
Okay, so Sundus, from here on, now we will continue in the next class. All right. The concept hasn't been finished. We will begin with the same concept in the next class. All right, guys. Okay. Okay, then Allah Hafiz. That's it for today.
Thank you,
Okay.
sir.
Thank
Bye, sir.
Yeah, you're most
Bye.
welcome, guys.
Love it.
Bye. Allah Hafiz.